So welcome everybody. My name is Nathan Jahnke. As Dr. Dole introduced me earlier, I'm a PhD candidate here at North Carolina State. And today I'll be talking to you about post-harvest handling techniques and the research that we've been doing here to improve storage life and vase life. So first we're going to go through some general outline of post-harvest practices of what we're recommending today, and then some post-harvest issues we're still having with those recommendations. The research that we've been doing will cover sort of a heat effect in storage. So what happens when you're storing at temperatures above what's recommended, and then what happens when you're storing peonies and cut stems for a really long amount of time. And finally, we'll touch on some preservatives that you might be able to incorporate and their effect on the storage life and vase life of cut stems. So just as everyone's been talking about, there's a lot of things to consider when working with peonies, and a lot of your production practices also translate into your post-harvest handling considerations, such as there's a lot of different varieties out there, and they have to be harvested at a particular stage in order to get their optimum vase life. A lot of that has to do with the bud stage that those plants are harvested at. And again, we're generally harvesting at a tight bud stage, that marshmallow stage, because it reduces the amount of mechanical damage that's going to happen during storage and shipping, but it also saves that vase life for your customer. And again, obviously harvesting is dependent on your general market, as Dave talked about. If you're going towards a farmer market, you might have a flower that's more open for it to be sold, or if you're going the wholesale market route, you're going to want a tighter bud stage. Today, we're mostly going to focus the research on temperature and how that affects storage life and vase life. Moisture, we obviously want to avoid that because that's going to increase our chances of disease during storage. And then preservatives, there's a few different things that can help improve the vase life of your peonies. So here are the general post-harvest practices for handling cut peonies. And a lot of this is outlined in Post-Harvest Handling of Cut Flowers and Greens, published by the Association of Specialty Cut Flower Growers. And generally, step one is to harvest at our correct bud stage for the target market, as we just talked about, removing our surface moisture, and then getting those stems cooled down as quickly as possible. So very limited amount of time from once you cut it into the cooler. Some places will use, if you're a very large grower, you'll have systems in place to do like forced air cooling through a box where you're pushing really cold air to cool down those stems. After that, you'll want to grade and bunch your stems. Generally, the price you're going to get for your stem is related to the stem length and the bud size, but that can differ on your market. There's some debate in the industry about whether you should hydrate before storage, and we actually did a project on that, so we'll be talking about that in a little bit. Step 6 is where most of the research I'll be talking about is focused, because most peonies, if you're storing for any length of time, you'll want to store them dry, generally horizontal, between 32 and 34 degrees. After storage, you want to recut or cut those stems and rehydrate them, generally using a commercial hydration solution, as this has a lower pH, and that's going to help the water uptake in your stem. And finally, you can do a sucrose pulse or a carbohydrate pulse to improve flower opening, but when a consumer gets their flowers, they might want to be using a flower food packet that has a small amount of carbohydrate in it to improve the vase life of those peonies. So with our storage, temperature, and humidity, the industry standard really, if you're a large grower, that standard is going to be about 33 degrees, so right above 0 or 32. And you're going to want to have a relatively high humidity. That'll reduce the wilting and desiccation that's going to occur. And some people will also help this situation through having a plastic lined box. And again, they're going to want those stems and leaves to be dry. The usual limit of this system is that stems are not stored longer than 4 weeks, because our vase life is already short compared to most cut flowers, that after that point, your vase life is going to be too short to ship it anywhere, and your customers aren't going to be happy with their product. There has been some work that we found on modified atmospheric packaging, and that's where the container that those stems are in, the concentrations of different gases in the atmosphere will be changed. And one thing that has helped is increasing your humidity through that system, as well as having lower oxygen concentrations, which have improved the storage life of cut stems. So the two different storage types, Dave touched on this, is one being dry horizontal. This is the more popular method that's gonna work for a larger volume of stems. It also slows your bud development, which again is important for preserving your vase life, but also reducing mechanical damage to those petals. And again, the limitation to that is about 4 weeks, and you could see some wilting and desiccation over long extended periods of time. You can store your stems in buckets with water, which prevents wilting. However, even at really low temperatures, close to 32, you can see your buds develop over time. So you generally don't want to extend that longer than about a week. Here at NC State, we had a few objectives with our research, and the main one was to improve the storage life of our cut stems. As John talked about, there's some gaps in the production right now, and even in your local area, if you're a small grower, you're only harvesting your peonies, as Dave said, for about 15 days. So peonies are relatively high value, so if you can extend your season past where your production, you can sell a high quality, high value cut flower. But we also need to take into account the vase life, which decreases with storage. So not only do we want to increase the storage life, but we also want to increase the vase life. And to do that, we looked at some different sub-zero temperatures or temperatures below 32 degrees. I'll be talking about the total vase life, which is a combination of how long those stems stayed as a bud and how long they stayed open. And all this research was funded by the North Carolina Specialty Block Grant Program. So our first experiment that we worked on, we're calling a short-term heat effect experiment. And this is helping us understand what happens when you store your stems at temperature warmer than the optimum or the industry standard, excuse me. And so we had peonies stored 0 to 8 days, sampling every 2 days. And you can see the list of temperatures here, with 72 being our room temperature and 33 being our industry standard. And we used Festiva Maxima, Carl Rosenfield, and Sarah Bernhardt. So in these graphs on the bottom, we have how long those flowers were stored, and that's again up to 8 days of storage, and then the total vase life on our y-axis. The red temperature, or red color, is our highest temperature. Orange is the next lowest, 39, and then 33. 39 is in there because a lot of growers, if you don't have a really good cooler, you might not be able to get down to that industry standard. So the main takeaway from these graphs with all three cultivars is really don't store your peonies at room temperature. The vase life's decreasing very quickly, but 39 and 33 are relatively similar through that 8 days of storage, and this is all dry. However, just because you're getting a vase life with these flowers, you have to think about the quality of them after their opening. And with these flowers, bud opening was slower at 39 and 33 degrees. So that can be important for preserving your vase life. Whereas if you wanted your flowers to open more quickly, you could store them at a warmer temperature. Say you need to get them open for a particular event, then don't put them in the cooler. Diameter, flower size, is an important quality trait, and that's even decreasing. Almost about an inch in diameter is lost over those 8 days of storage, but that's again best preserved at 33 and 39, 40 degrees. Necrotic petals is something we really saw, and you can see examples of that on the right side of your screen, but those really didn't occur unless they were at 50 or 72 degrees. So really important again that we store at that industry standard or below 40. So the main meat of this presentation, though, is long-term storage. And we stored flowers the first year for up to 12 weeks, 3 months. And again, we had a temperature of 38 degrees, which is a temperature that most everyone should be able to obtain. Then our standard at 33, and then our sub-zero temperature, which is below 0 Celsius, is at 26. So this is really looking at how far can we push the envelope in terms of temperature, because it has been shown that even for edible crops, storing flowers below freezing has been, or storing crops below freezing has been really beneficial for quality. So this is Festiva maxima, one of those cultivars that's been around for over 100 years. And this is the total vase life here shown in this graph. And again, we're storing these flowers for 12 weeks. Blue is the coldest temperature, red is our warmest temperature, and green is our industry standard. So after 12 weeks of time, we had about a vase life of 5 days, which is actually fairly good, but still might not be good for shipping these stems out to a customer when that takes 2 days at a time. This is a picture of a flower with no storage, but you might be wondering, what are these flowers looking like after they've been stored for long periods of time? And this is a 7-week flower that has been stored for 7 weeks. So a little bit different, but still really good quality in compared to no storage. So next up is Monsieur Jules Ali, which is another very common cultivar in the trade. Again, what that looks like with no storage. But when you compare the two when they've been stored for that length of time, Monsieur Jules Ali did much better, actually handled 26 degrees Fahrenheit for 12 weeks and still had a vase life. And yes, these stems were actually frozen. There was ice coming out of them. But still, our industry standard at 33 degrees preserved that vase life the best over 12 weeks. After 10 weeks of storage, we still had relatively good looking flowers, but we'll talk more about how the quality changes when you're storing at different temperatures. I do want to draw your attention to 2 different time points in these graphs. At 4 weeks, that's again where we've generally said you're not going to store longer than that, but really our industry standard at 33 and the warmer temperature of 38 was fairly similar up to 8 weeks of storage. But once you're getting past that 8 weeks of storage, you really need to be using a temperature closer to 32. We did have quite a few issues with flowers that have been stored for long periods of time, such as flowers not opening all the way. The flowers were getting smaller when they opened, different deformities, petal loss, especially at our warmer and really cold temperature, desiccation and stem collapse, as you can see here, and then an increase of disease. So we definitely had to reevaluate that going into year 2. But first we'll look at some unopened flower data. We rated flowers as being failed to open, partially open, and fully. And the next few graphs, we're going to look at how many, or the percentage of flowers that failed to open. So we combined the fully and partially open, considering that you could still market a flower that partially opened. So this is Festiva maxima, and this graph on our right shows the percentage of flowers that are failing to open over our storage time. And the main takeaway again here is that 33 degrees allowed a larger percentage of our flowers to fully open after 12 weeks, and that was about 70%. But when you get to our warmer temperature of 38, there's basically no flower that had a chance to open at all. So really important temperature control here for long-term storage up to 12 weeks. So this is a pretty slide in a sense. But the first column here shows flowers that had not been stored at all. And then everything to the right of that is a deformity in flower shape that we saw throughout the storage experiment. And generally, this deformity that we're seeing is happening at our higher and lower temperature, but it increases with time. And again, this is just emphasizing that 33 degrees, the industry standard, has been really helpful in reducing the number of flowers that are deformed, and Monsieur Jules Ali has been the best performer in our experiments, with about only 20% of them really being deformed after 12 weeks of storage. So that was year 1 of our experiment, and we obviously need to do some refining of that in order to improve quality and vase life. So in year 2, we got rid of our warmest temperature because we knew that 33 degrees was for sure better than that warmer temperature, but our sub-zero temperature caused a lot of issues with deformity and stem collapse and such. So we pulled that up to about 31, right below freezing. And we also included some pre-storage pulses here for about 2 hours at 40 degrees. Now this is addressing that, do you need to hydrate before storage? So we used a commercial hydrator and then a 20% sucrose solution. And that's fairly high for a lot of floral preservatives, but that's been useful in previous literature that we found. We also extended this experiment to 16 weeks, so that's getting us to 4 months of storage. So this graph here shows the total vase life, and I combined all three cultivars, Festiva Maxima, Monsieur Jules Elite, and Sarah Bernhardt. And the big takeaway is that at 31 degrees, we saw slightly higher vase life than at 33. So it wasn't that much, about 0.2 days for Festiva, 0.6 for Jules, and 0.3 for Sarah Bernhardt, but it is better, at least in our experiments. With our pre-storage pulses, there wasn't much benefit there. Slightly higher vase life for Festiva and Jules with a hydration solution, but Sarah Bernhardt, it didn't really affect it at all. Diameter, as I said, that decreased in last experiment, but it was a little bit higher, again at 31 degrees Fahrenheit, and we lost about 1 to 1.5 inches in diameter over that 16 weeks. So that's something to keep in mind, that even though you have a flower that has a potentially good vase life after that amount of time, it's going to be lesser in quality. However, there were a lot of benefits that we saw at holding our stems at 31 compared to 33. Here you can see Monsieur Jules Elite not stored, then after 14 weeks and after 16 weeks of storage. So a relatively good looking peony after 4 months in a cooler for no water. So our flower deformity was actually reduced by 10 to 25% at this temperature compared to 33. This is showing Sarah Bernhardt and the percentage of flowers that failed to open over those 16 weeks of storage. And at 31 in the dotted line, you can see there's about 10 to 25% fewer flowers that are failing to open at that temperature as well. And this is a good segue into Gary's talk on disease, but we also had a lot less disease in flowers that developed botrytis at 31 degrees compared to 33. So I put together this table sort of just to emphasize that our pre-storage preservative pulses, again, that's 8 hours at 4 degrees C, really didn't have an improvement on any different quality traits of our peonies. So the main thing was that our sucrose and commercial hydrators increased the water content in the stems, which obviously was lost a lot quicker during storage. So may still be helpful in the short-term case, but not recommended for any benefit in the long term. So here are just some quick conclusions on the research that we did. Short-term storage, you really want to keep that below 40 degrees and not longer than 8 days. And our quality is going to be better at that 33 degrees. For long-term storage, you could potentially store your stems for 16 weeks with a minimal loss in vase life and quality. And 31 degrees was for sure better than, in our experiments, than 33 degrees. But I really do want to emphasize that if you are able to get down to this temperature, do some on-site testing with your own varieties that you have, because peonies do differ quite a bit. And then again, our pre-storage preservative pulses really weren't beneficial at all. So when you look back at those general post-harvest practices, there's a few areas that we can now adjust and make some different recommendations. In number 5, we can really say that hydration, for long-term at least, is really optional and not that helpful, but you may still want to do it in the short-term case if you're shipping your stems and you want them to look really fresh and full of water when they get to your consumer. But especially in step 6, we can reduce that 32 down to 31, potentially enabling us to store peonies for 4 months at 31 degrees. I definitely need to thank everyone who's helped me out here at NC State with my different experiments. I'm probably missing some names on there, but I've had a lot of great support here. And then, of course, all of the sponsors and supporters who have given us plants and funding for these different experiments. So with that, we can take some questions. All right. I'll start at the bottom here. Okay. Any recommendations for a good fan setup to ensure stems are dry from dew or rain before they go into the cooler? I've not have a lot of experience with that. Dave, do you have any comments? Oh, you're muted. There you go.
There you go. As far as a fan to dry the plants is to space the plants out in the bucket, and just any fan would work. But the idea is just give room for them to dry out. In other words, you don't want to pack the bucket full of 50 stems and expect the fan to dry them out. You want to spread them out, maybe put those 50 stems in 5 different buckets, then have them dry out with the fan. But if you're storing them in a bucket of water in the cooler, you don't have to get them as dry as if you're storing them in the dry storage. But you still want to get as much of the moisture off before it goes in the cooler. But your cooler will still dry them off more. So again, just don't pack them as tight when they go in the cooler.
So someone's asking, why not use a liner inside the box to reduce hydration? Yeah, there are people that do use plastic liners within their box to prevent that. And there actually are some products from different companies that claim to help with hydration and loss of water during storage. Which Crystal and Floral Life products should we be using? So both companies actually have hydration solutions and holding solutions. So whichever one you can get through a supplier, you could most likely just pick a different hydration solution and use that in your processing. Any research on modified atmosphere packaging for peonies? So mentioned that a little bit, that there has been some work, not here at NC State, but looking at reduced oxygen concentrations, and those seem to be helpful, but I can't speak on specifics of their data.
I can chime in a little bit on that. There's been a fair amount of work. Unfortunately, the inconsistency of response has prevented, I think, widespread implementation of the technology.
Any research on using an ozone machine in the cooler? I know that Ron Eilingsworth in Alaska has been doing some work, and Gary, maybe you can speak on that a little bit. I don't know if you've done specific things with them.
I'll show some slides where we've been monitoring spore loads in the air, pre and post ozone treatment. It clearly, I mean, in other situations, it's been shown to be an effective way to reduce the inoculum levels. Whether or not it eliminates it, that's another question.
Okay, we'll let you expand upon that a little bit more in your talk. Dry and 80% humidity in storage. This is confusing me. Please elaborate. So just because you have high relative humidity does not mean that you have water condensating on different things. So if you look at your cooler, you may be able to adjust that, and that is about the water content within the air, and that's going to help reduce the water that's evaporating from your stems. So dry specifically means that those stems aren't in a bucket of water being able to uptake it.
Another thing to point out is that relative humidity is also relative to the temperature.
Right.
So when you've got a 80-degree greenhouse, 80% humidity is damp. You feel like you're going to sweat. You go in a cooler that's 34 degrees and 80% humidity, you hardly even feel that there's any humidity in the air, because the amount of humidity, it's 80%, but it's much drier still compared to 80% on a storm, a humid day in the summertime. It's a different kind of humidity measurement. It's relative humidity.
Okay. Is horizontal storage better because of space or for storage time? In my experience, horizontal storage is helpful because it really allows you to store more. But Dave, you may have another take on that.
If you're storing on dry storing, you want to lay them down. It's much easier. They're not geotropic like a gladiola or something that's on a curve. So laying them down in the boxes will let you store lots more plants or more stems in the cooler.
Can they be completely wrapped in a liner? Would you have botrytis issues? You could do that. You would just have to make sure that your stems and the environment within that wrap is very similar to what you're placing them inside the cooler. Because if your stems are warmer going into a cold cooler, they could condensate and then provide a place for disease to develop. So how do you get the humidity up to 80%? Good question. I guess one way you could do that is by storing a bucket of water in your cooler.
Yep. Easiest way.
Yep. But if you have a system, it could potentially be included in your system as well, that you could operate it like that. But yeah, the water is easiest.
I'll add that a cooler full of flowers that have foliage, the humidity gets up there on its own.
How many flowers can a grower harvest per acre once established? I'd have to ask somebody who grows a lot of peonies and ask them. I never measured by the acre.
It probably depends on how experienced you are at
Yeah.
identifying the bud stage.
Yeah, but it can be a lot. Maybe Bernie could chime in on how many he gets off his 100 acres.